the solid state physics. So if you are new to my channel, please subscribe my channel, press the bell icon for notification, also like and share my videos. So let us start today's class. What is solid state physics? It is the branch of physics that deals with the study of solids and their properties. Solids can be defined as materials having definite shape and structure. The rigidity of solids is due to translatory motion of the structural units of solid. They have only vibrational motion about their mean position. Classification of solids. Solids are classified into two types. One is crystalline, another one is amorphous. Crystalline solids which possesses periodic or regular arrangement of atoms or molecules or ions. Amorphous solids which have the irregular arrangement of atoms or molecules or ions. Some of the examples for crystalline and amorphous solids: sodium chloride, diamond and sugar are some of the examples for crystalline solids. So glass is one of the best example for amorphous solid, as well as rubber and plastic are the examples. Once we understand the crystalline solids, so we can understand crystal structure. So as we know the definition for crystalline solids, that is regular arrangement of atoms or molecules or ions. If we replace these units by points in space called space lattice or lattice simply, so each point is called a lattice point. If we draw a small circle to below of it, that is called the basis. So repetitive group of atoms or molecules or ions is called basis. So lattice plus basis will make crystal structure. So what is unit cell? A unit cell is the smallest portion of a crystal lattice that shows the 3D pattern of the entire crystal. All crystal lattices are built up of repeating unit cells. So this is the structure of unit cell in 3 dimensions. So we can see here 3 edges denoted by A, B, C and 3 angles denoted by alpha, beta, gamma. The angle alpha, which is opposite to the edge A, which is made by edge B and C. Similarly beta and gamma. So these angles are called interfacial angles. So the edges and interfacial angles will make the cell parameters. There are 3 different types of unit cell. So we can have different varieties. First one is simple cubic, second one body centered cubic, third one face centered cubic. What is simple cubic structure? In this case, the constituent particles are present at the 8 corners of the cube only. So we can see in this figure there are 8 atoms at the corner. So these 8 atoms are shared with 8 unit cells. So 8 into 1 by 8 is equal to 1 atom. That is 1 atom per unit cell of simple cubic structure. Body-centered unit cell. In this case, the constituent particles are present at the 8 corners of the cube as well as at the center of the unit cell. So we can see there are 8 atoms at the corner, 1 at the center of the body of the unit cell. So 8 corners atoms are shared with 8 unit cell, and the at the center, that is 1 atom. So 1 plus 1, there are total 2 atoms per unit cell of body centered cubic structure. So face centered unit cell. In this case, constituent particles are present at the 8 corners of the cube as well as at the center of each of 6 faces of cube. So there are 8 atoms which are going to be shared with 8 unit cell. So 1 atom, it will make 6 faces which have 1 atom at the center of each face. So they are going to be shared with 2 unit cell, that is 1 by 2. So 6 into 1 by 2, 3 atoms. So total number of atoms in a unit cell is 3 plus 1, 4 atoms for FCC unit cell. What is packing fraction? So atomic packing fraction is defined as the ratio of volume of atoms occupying the unit cell to the volume of unit cell. So for simple cubic structure, we have the structure like this. So volume of atoms in unit cell. Atom is a spherical in shape, therefore volume of a sphere will be 4 divided by 3 pi r cube. There will be a 1 atom per unit cell of a simple cubic structure, 1 into 4 by 3 pi r cube. Then volume of unit cell, that is given by a cube. So there will be 2 atoms at the corner. If we take distance, that is r plus r, 2r, then 2r cube is equal to 8r cube. If we take the ratio of volume of atoms in unit cell to the volume of unit cell, that is equal to pi by 6, which is equal to 52%. So the packing fraction for simple cubic structure is 52%. Next comes body centered cubic structure. So here we have 2 atoms per unit cell, 2 into 4 by 3 pi r cube, and volume of unit cell a cube is equal to 4r divided by root 3 cube. If we take ratio of these two, we will have the 68% of packing factor for BCC structure. FCC structure. So here there are 4 atoms per unit cell. Then volume of unit cell is given by 4 into 4 by 3 pi r cube. So volume of unit cell a cube is equal to 4r by root 2 cube. If we take ratio of these two, that is 74%. What is coordination number? The number of atoms nearest to an atom in the crystalline structure is called the coordination number. The coordination number for BCC, SC and FCC structure are 8, 6 and 12 respectively. So in this table we have the basic information for all the 3 different types of unit cells. So number of atoms for SC, BCC and FCC, that is 1, 2 and 4. Similarly coordination number 6, 8 and 12. Packing factor 52%, 68%, 74%. Atomic radius a by 2, root 3 a by 2, root 2 a by 4. Volume is same for all 3 structures because it is cubic structure, a cube. Primitive unit cell. We understood unit cell. Then what is primitive unit cell? A primitive cell is a unit cell that contains exactly one lattice point. It is the smallest possible cell. If there is a lattice point at the edge of a cell and thus shared with another cell, it is only counted half. This is the primitive cell in 3 dimension, and this is the primitive cell in 2 dimension. Primitive cell can be drawn in any different ways, and number of atoms per unit primitive cell is 1. That is 8 atoms are going to be shared with corner atoms are going to be shared with 8 unit cell. That is 8 into 1 by 8. That is 1 atom per primitive unit cell. And one more important point I want to add here: all primitive cells are unit cell, but all unit cells need not be primitive cell. You have to keep in mind this point. So Wigner cell. There is a special type of primitive cells known as Wigner cell. Wigner cell of a lattice point is defined as the volume that encloses all points in space which are closer to this particular lattice point than to any other. So the Wigner cell in 2 dimension, it looks like this. So how we can get the Wigner cell? There are 2 steps involved. First one, we have to draw the straight lines joining the lattice points nearby. Then we have, in second step, we have to draw perpendicular line at the midpoint of this line joining the lattice points. So we will have an area enclosed within that closed shell, that is called Wigner cell. This is all about basic information about solid state physics, especially about crystal structure. So if you like this video, please like, share and subscribe my channel. Thank you for watching.